Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and you are also doing your studies properly and your studies are going on well. This video is part 8 video on the chapter of rational numbers, where I will discuss about the multiplication, division and their properties of rational numbers, and we will discuss about the multiplicative inverse and multiplicative identity, and we will discuss all these concepts with some illustrative examples. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my rough notes prepared on the left hand side, and on the right hand side I will do all the discussion and with some illustrative problem solving. Okay, so this video is about multiplication of rational numbers and division of rational numbers and the properties of multiplication and division of rational numbers. So how do we multiply two rational numbers? Now you can see that in the notes. So while I speak, you can please follow the notes and you can take screenshot of the notes. So product of one or two or more rational numbers is equal to product of their numerators, of all the rational numbers divided by product of the denominators of all the rational numbers. So as an example, you can see, you can see that the product of p by q, and if p by q and r by s and t by u are rational numbers, then p by q multiplied by r by s will be equal to p into r divided by q into s. That is, we multiply the two numerators p and r divided by the product of the denominators q and s. Similarly, if you have to multiply three rational numbers, we just multiply all the numerators. So p by q multiplied by r by s multiplied by t by u equals to p into r into t divided by q into s into u. Okay, now in this context, please note that 1 is known as the multiplicative identity for rational numbers or for rationals. Now wherever you will see R and S, it means rational numbers. Now why 1 is the multiplicative identity? Because if you multiply 1 with any rational number, the result is the rational number itself. It is like additive identity of rationals, which is 0. So if you add, you know that if you add 0 to any rational number, the result is 0. Similarly, if you multiply 1 with any rational number p by q, the result is p by q. So 1 is the multiplicative identity for rationals. Also, if you multiply any rational number with 0, with the rational number 0, the result is 0. So you can see that if you multiply p by q with 0, the result is 0. And even if you multiply, if you have a multiplication of two or more, a multiple number of two or more rational numbers, and one of them is 0, then the entire product or the result is 0. Okay. Also, there exists a multiplicative inverse of all non-zero rationals. So for all non-zero rationals, that is a rational number p by q which is not equal to 0, it has a multiplicative inverse. Now what is multiplicative inverse of a rational number p by q? It is the reciprocal of p by q. Multiplicative inverse of a rational number is also known as reciprocal of the rational number. It is so it is nothing but 1 by the rational number. So multiplicative inverse of p by q is equal to 1 by p by q. Now this will be equal to q by p, but the reciprocal of any number is written as the number as a base and the power as minus 1. So multiplicative inverse of p by q is equal to p by q raised to the power minus 1. It is a kind of exponential form. You have studied exponents in your previous class. So where in the base is p by q and the power exponent or the index is minus 1. Now, so p by q, the multiplicative inverse of p by q is ultimately q by p, that is you reverse the numerator and the denominator. The notation is multiplicative inverse of any rational number p by q. The notation is p by q to the power minus 1, but in actually its value is q by p. So if you have if you have two rational numbers, if you have two product of two rational numbers, let's say p by q and r by s, if the product is 1, then you will know that p by q and r by s are multiplicative inverse of each other. Okay, I think I am going too far with the theoretical part. Let's try to understand the concepts with some examples. Let's try to understand the products. So I will, as illustrative examples, I will take examples from the exercise itself. So addition and multiplication, the exercise are exercise 1D and I think it's a 1D and 1E. So I will take some examples from this exercise to illustrate the concepts that I am discussing. So regarding product of rational numbers, so this is very easy, but still, let's say we have to find the product of minus 9 by 4 multiplied by 5 by 4. So we just multiply the numerators, that becomes the numerator of the product, and we multiply the denominators. So this is now minus 45 by 16. Minus 45 by 16 is the result of the product of minus 9 by 4 and 5 by 4. Okay, let's take another example. Minus 13 by 5 multiplied by minus 10. Now this is nothing but the rational numbers are minus 13 by 5 multiplied by minus 10 can be written as 1, minus 10 by 1. So now you multiply the numerators, that will be the numerator. The numerator will be the product of all the numerators, that is minus 13 multiplied by minus 10, and the denominator of the result of the product will be the product of the denominators. So this becomes minus 13 into minus 10 is 130 divided by 5. Now you can further simplify this to convert this rational number in a standard form, and this will be 26. Okay, I think this is okay. Now let's take an example. So let's say you have to do let's say minus 7 by 6 multiplied by 24 multiplied by, let's say, 3 by 14. We have three rational numbers, minus 7 by 6, 24 and 3 by 14. So 24 you can always represent any integer as a rational number, where as the denominator will be 1. So this becomes you take the product, the numerator will be the product of the numerators, that is minus 7 multiplied by 24 multiplied by 3, and the denominator will be the product of the denominators, 14. So now if you do cancellation, you will see 6 divides 24 with 4, 7 divides minus 7 with minus 1, and 14 with 2, and 2 divides 4 with 2. So this is the final result is minus 1 into 2 into 3, which is minus 6. So I hope the product of rational numbers is clear. Okay, and the multiplier one is the multiplicative identity. It is quite simple, straightforward. I do not think I have to show it with an example. And also any rational number, if you multiply it with 0, the result is 0. Okay, there exists a multiplicative inverse of all non-zero rational numbers. Okay, let's try to understand this with some examples. So let's say we have to find multiplicative inverse. I mean, short for multiplicative inverse, I am writing mi. So let's say mi of minus 7 by 24. We have to find the mi of minus 7 by 24. So this is the basic concept is formula is multiplicative inverse of any rational number, or the reciprocal of any rational number is 1 by that rational number. So it will be 1 by minus 7 by 24. Now this is the basic formula, and you know that if you simplify this, this is becoming 24 by minus 7. Now directly what you can do is that the multiplicative inverse of any rational number is you just interchange the numerators and the denominators. So it becomes 24 by minus 7. Now this is not in standard form. You have to, if not, it is better you convert any results in rational number to standard form. If you cannot at least do the standard form, at least make the denominator positive. So this is equal to minus 24 by 7. Now what will be mi multiplicative inverse of minus 6? Now minus 6 we know is minus 6 by 1. Now if you interchange the numerators and the denominators, it becomes 1 by minus 6, and if you convert this to standard form, that is you make the denominator positive, it will be minus 1 by 6. Okay, so now you can obviously see that the product of any rational number, and its multiplicative inverse, which the notation of a multiplicative inverse of a rational number p by q is written as in the exponential form with the base as the rational number and the power of the exponent as minus 1. Now this always results to 1. The product of a rational number and its multiplicative inverse is always 1 provided the rational number is not equal to 0, that is non-zero rational numbers. Always remember, multiplicative inverse exists only for non-zero rational numbers. And okay, and also that if you have something like this, if you have something like p by q into multiplied by the product of two rational numbers is given as 1, then you can say that mi multiplicative inverse of p by q is equal to r by s, and multiplicative inverse of r by s is equal to p by q. Okay, so as an example you can see that so if you have this kind of equation, let's say 2 by 3 multiplied by some unknown rational number, let's say some unknown rational number is equal to 1, then you immediately know that x will be equal to the multiplicative inverse of mi multiplicative inverse of 2 by 3, that is equal to, we know multiplicative inverse of any rational number, you just reverse the numerator and the denominator, 3 by 2. Okay, so multiplicative inverse, I think it's clear. And okay, so one important thing is that there are only two numbers or rational numbers which are equal to their multiplicative inverse. Only two rational numbers. Now, and these numbers are 1 and minus 1. So what is multiplicative inverse of 1? It is 1, we know the notation is 1 to the power minus 1, but actually mathematically the formula is 1 by the rational number, which is 1, which is equal to 1. So you see the multiplicative inverse of 1 is equal to 1. Also you see multiplicative inverse of minus 1 is equal to the notation is minus 1 to the power minus 1, but if you concept wise mathematically we know that minus 1 is minus 1 by 1, and if you interchange the numerator and the denominator of minus 1 by 1, the rational number minus 1 by 1, it will be 1 by minus 1. Now if we convert this rational number 1 by minus 1 so that the denominator is positive, it will be minus 1 by 1. This is equal to minus 1, which is equal to the original rational number minus 1. So 1 and minus 1 are the two only rational numbers or numbers which are equal to their multiplicative inverse. Okay. Now comes the division of rational numbers. How do we divide a rational number with another rational number? Of course, the rational number by which we are dividing, that has to be a non-zero rational numbers. So let's say if we are dividing a rational number p by q, if we are doing p by q divided by r by s, where p by q and r by s are two rational numbers, this is only valid only for r by s has to be not equals to 0. That is, r by s has to be a non-zero rational number. Division, as you know, in mathematics division we never divide by 0. So here also the rational number by which we are dividing, which is r by s, should not be equal to 0. Now we express the division of two rational numbers using the concept of multiplication of rational numbers and the multiplicative inverse. Now this is equal to p by q multiplied by the multiplicative inverse of r by s. So the rational number p by q divided by rational number r by s is equal to the rational number p by q multiplied by the multiplicative inverse of r by s. Now what is multiplicative inverse of r by s? It is, we just change the numerator and the denominator, interchange the numerator and the denominator, so it is s by r. Now this is also, you can as notation write it as p by q multiplied by r by s to the power minus 1, which is the notation for the multiplicative inverse of r by s or the reciprocal of r by s. Okay. So this is the basic concept or formula. And also note that if you divide any rational number by the same rational number, and that rational number should not be equal to 0, then the result is 1. So if you divide a rational number p by q by itself, that I am dividing p by q by p by q, the result is 1, provided that the rational number p by q should not be equal to 0. And also if you divide 0, and if you divide 0 by any rational number p by q, where p by q should not be equal to 0, p by q should not be equal to 0, this is also equal to 0. So these are the main concepts of division of rational numbers. Now so these are the division of two rational numbers. Now what about the division of three or more rational numbers? So if you have, the concept is same. So if you have to if you have this kind of expression, you have to simplify it. Let's say p by q divided by r by s divided by t by u. So how do you simplify this or evaluate this? You have studied in your previous classes the Bodeman's rule. That is, first in an expression having multiple various kind of mathematical operations like addition, subtraction, division, multiplication, you first apply the brackets, the Bodeman's rule. Bodeman's rule. First bracket, then comes what is O? I forgot. Anyway, D for division, M for multiplication, A for addition, S for subtraction. What is O? Bodeman's rule. Brackets, and then I'm sorry, I forgot O. Anyway, so as per this rule, how do you evaluate this? How do you evaluate this? I think you will evaluate the division from left to right. Now the question is, do I evaluate this as P by Q divided by R by S and then whole divided by T by U, or we evaluate this as P by Q divided by, we first do the division of R by S and T by U. Which of these two methods we will apply to evaluate a division of 3 or more rational numbers? I think this is the way that you should operate the division operators, or if you will execute the division operation on the rational numbers from left to right. Now, if this is the exact rule, I am not sure at this moment if this is the rule that you need to apply for doing division of 3 or more rational numbers, that is from left to right, you evaluate the division taking 2 rational numbers at a time, then this will be first, if you do P by Q divided by R by S, it becomes P by Q multiplied by the multiplicative inverse of R by S, which is S by R. So this becomes this, and then if you do, let's say, T by U, so this becomes now P by Q using the same concept of division. This becomes now multiplied by U by T. So this is the result we are getting if we apply the first rule. Now if we apply the second rule, if we apply this rule, what it is becoming, what the result is. So it is P by Q divided by, first we simplify R by S divided by T by U. So that becomes R by S multiplied by U by T, that is the multiplicative inverse of T by U. Okay. So now if we apply the division using the concept of multiplication and multiplicative inverse, what we have, it will be P by Q multiplied by R by S multiplied by U by T minus 1, because we know that the division of one rational number by another rational number is equal to a multiplication of the first rational number with the multiplicative inverse of the second rational number. Now what is this? What is this? This is nothing but, you can see, this is RU divided by R by S multiplied by U by T is basically RU by ST as per the multiplication of two rational numbers. So this is minus 1. So this becomes P by Q multiplied by R U by ST to the power minus 1, meaning the reciprocal of RU by ST. So this is equal to, we know the reciprocal of any rational number, we know this will be equal to ST by RU. That is, we just interchange the numerator and the denominator. Okay. Now is this equal to the previous result that we got? In the first result, what we got? What was the first result we got? The first result was this. This is equal to PSU divided by QRT, and the second result we got is equal to PST by QRU. It is different. It is different. It is not the same. So you have to be careful when evaluating this kind of expressions having divisions, multiple divisions of 3 or more rational numbers. Now I think, in my opinion, the result PSU by QRT is the correct one. That is, we take take two rational numbers at a time from the left hand side and operate the division, and this way we proceed towards the right hand side, because there could be more than three rational numbers. We take two rational numbers at a time from the left hand side, evaluate the division, and then we proceed this way towards the right until all the division operators are evaluated. Okay. Now let's come to the discussion of properties of multiplication and division of rational numbers. The first is the closure property. That is, we need to check whether multiplication and division, they obey the closure property. That is, if you multiply two rational numbers, is the product also a rational number? The answer is yes. So multiplication, as you can see in the notes, multiplication obeys the closure property. That is, for any two rational numbers, p by q and r by s, their product is also a rational number. Whereas the division operation is also obeys the closure property. That is, if you divide any rational number p by q by another rational number r by s, the condition is that the rational number by which you are dividing r by s, it should not be equal to 0. So if p by q and r by s are rational number and r by s is not equal to 0, then definitely p by q divided by r by s is also a rational number. So division and multiplication obeys the closure property. But for division, you need to be careful that the divisor, the r by s, that is the rational number with which you are dividing, is not equal to 0. So this is closure property. Commutative property. Now multiplication obeys the commutative property, but division does not obey the commutative property. Now what is commutative property? In doing a multiplication of two rational numbers, you can change the order. So p by q multiplied by r by s will be equal to r by s multiplied by p by q. Whereas for division, it is not necessarily true that p by q divided by r by s is equal to r by s divided by p by q. This will not necessarily be true all the time. So division actually does not follow or obey the commutative law, whereas multiplication obeys the commutative law. Associative law. Now what is associative law? That is, when you are applying an operation on three rational numbers. So in this case we are talking about multiplication and division. So if you multiply three rational numbers, let's say p by q, r by s and t by u, if you are multiplying these three rational numbers, then you can change the order. That is, first you can multiply r by s with t by u, and that result you can multiply with p by q. And also you can first multiply p by q with r by s, and then the result you can multiply with t by u, as you can see in the notes. So basically it is saying that if you have three rational numbers, let's say 2 by 3 and 4 by minus 1 and let's say 7 by 8, I am taking random rational numbers. Please do not worry about whether they are in standard form or not. So it means that if I want to do multiplication of all the rational numbers or these three rational numbers, I can change the ordering, I can change the grouping, basically change the grouping of the rational numbers in doing the multiplication, meaning I can first multiply the first two rational number, that is 2 by 3 multiplied by minus 2 by 3 multiplied by 4 by minus 5, and then the result, whatever the result will be, I will multiply with 7 by 8. This will also be equal to, if I multiply first the second and the third rational number, and then whatever the result will be, if I multiply that with the first rational number, these two will be equal. So this is the associative law. So multiplication obeys the associative law, whereas division does not obey the multiplication law. As you can see in the notes, it is not necessarily the case, always the case, that p by q divided by r by s and this whole result divided by t by u will be equal to, it will not be the case, always the case, that it will be equal to p by q divided by the result of r by s divided by t by u. So division does not obey associative law, whereas multiplication obey associative law when they are applied on rational numbers. Now, another thing is the last property is distributive law over addition and subtraction. Just like you have no distributive law over addition and subtraction. What does this mean? So basically, it is said the multiplication is distributive over addition and subtraction. That is, multiplication obeys the distributive law over addition and subtraction. What does it mean? If you have an expression like this, if you have p by q, so let's take let's take some examples. Let's say if you have an expression like half multiplied by 3 by 4 minus, let's say, 2 by 3, if you have this, or plus, let's say plus, if you have this, then you can distribute the multiplication over the addition, which basically means this will be equal to, you first you multiply half with the first rational number in the addition operation, and then you add the result with, then you multiply the half with the second rational number in the addition operation. So this rule is the distributive law of multiplication over addition. That is, you distributed the multiplication over addition. So basically the formula is that for any kind of numbers, not only rational numbers, for any kind of numbers, if A, B and C are numbers, and if you have this kind of expression, then you can write it as A multiplied by B plus A multiplied by C. This is the general concept of distributing multiplication over addition. Now this also works with subtraction. That is, if you have, so you will have, if you are multiplying half the rational number 1 by 2 with the rational number which is a subtraction of 3 by 4 and 2 by 3, if you have to simplify this, then you can distribute the multiplication over the subtraction. That is, you first multiply half with the first rational number in the subtraction, and then you, from this result, you subtract the result of multiplying half with the second rational number in the subtraction. So this is the formula of distributing multiplication over subtraction. So multiplication is distributive over addition and subtraction, whereas the division is not distributive over addition and subtraction, meaning you cannot write that half, let's say half, it is divided by 3 by 4, let's say it is plus 2 by 3. Division is not distributive. Now, as you can see in this case, in this example, half divided by the result of 3 by 4 plus 2 by 3, you can see that I can indeed write it as half divided by 3 by 4 plus half divided by 2 by 3. But why it is said that division is not distributive over addition or subtraction? In general, I mean, for some cases it could be true, but it is not necessarily the case that always division is distributive over addition or subtraction, because consider this case. If it was like this, 0 minus half, now this is a perfectly fine expression. This value, the value of this result of this expression is actually half divided by minus half, which is actually equal to minus 1. But if you apply the distributive law, if you apply the distributive of division over subtraction, you will have something like this. and now you can see you are in trouble because we never divide. In mathematics, we never do division by 0. Half divided by 0 is not valid, is an invalid. So you cannot apply. So in this specific problem example, you cannot distribute the division over subtraction or addition. So it is not necessarily the case that always division will be distributive over subtraction or addition. For some cases, for some problems, for some rational numbers, it may be the case. So in general, it is said that division is not distributive over multiplication or addition. Okay. So these are all the concepts basically that for this video about addition and subtraction of rational numbers and their properties which are closure property, commutative law, distributive law, associative law, and also the concepts of existence of multiplicative inverse and multiplicative identity. Okay, so I think I have explained all these concepts with some examples. I don't think I need let me see if I can do some more problems that can possibly clarify the concept. Let me see. Okay, so there are some problems. Let me do. So you will be asked to what is the value of, let's say, 1 by minus 3 whole to the power minus 1. Whenever you see any rational number whole to the power minus 1, you mean it is asking. So this is basically is asking what is the reciprocal of 1 by minus 3, or what is the multiplicative inverse of 1 by minus 3. So 1 by minus 3 whole to the power minus 1 is basically equal to reciprocal of 1 by minus 3, or mi multiplicative inverse of 1 by minus 3. And we know the reciprocal of a rational number or multiplicative inverse of a rational number is nothing but we just interchange the numerator and the denominator. So it will be minus 3 by 1, which is equal to minus 3. Let's say minus 4 by 9 whole to the power minus 1. Now you can straight away say that the result is 9 by minus 4. You just interchange the numerator and the denominator of the rational numbers which has been raised to power minus 1. Now this 9 by minus 4 is not in standard form. You just have to convert it to standard form. So it will be minus 9 by 4. Okay. Okay. Okay, fine. I think these are enough examples to illustrate the concepts of addition and multiplication of rational numbers and the two concepts of multiplicative inverse and multiplicative identity. In the next two videos, I will solve the problems from exercise 1D and 1E. So exercise 1D is about the multiplication of rational numbers, and exercise 1E is about division of rational numbers. I will not solve all the problems from exercise 1D or 1E. I will solve selected problems that will cover the major variants or all the variants of the problems from each exercise 1D and 1E. So please stay tuned for the next video where I will solve selected problems of exercise 1D and 1E that will cover the concept of addition and multiplication of rational numbers. So after that, the next video, theoretical video, will be about an important property of rational numbers, and which is that a rational number that okay, I will discuss in that video only how to find rational numbers between two given rational numbers using some particular property. I will discuss in the next theoretical video. So next video will be solving the problems of exercise 1D and 1E based on addition and subtraction of rational numbers. Please stay tuned for that. I hope this video was beneficial If it is, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So until the next video, take care and bye.